Let's do a couple of problems where we're going to solve an equation that starts out with a radical. And I think both the examples I'm going to do end up having a square root. So let me write down the first problem to solve, and then we'll take a minute to review the steps. So I'm going to solve this problem. Square root of 9 minus 5x equals 8. All right, let's just take a minute and talk through the steps that you follow to solve these kinds of equations. Whenever you have an equation with a radical, the first thing you have to do is to get the radical by itself on one side. Just like what we did when we had equations with absolute values. You had to get the absolute value by itself on one side. Now we have to get the radical by itself on one side. Then once we do that, we're going to check the number on the side opposite the radical. Especially if you're dealing with the square root. If the number on the opposite side is a negative, then we're not going to do any math, but we're going to stop and in a sense, it's going to be no solution, because you can never have a square root equal a negative number. If the number is positive, then we're going to do some math. So once again, the steps. Get the radical by itself on one side, and then second, you check the number. Now the big thing about, or the last thing that's very important about these equations with radicals is, when you finish the problem, you've done the math, you've got your solution. Most of the time, up until now, whenever you solved an equation and you got a solution, it was optional whether you wanted to check your solution. If you wanted to make sure you did the math correct, then you could check your work to confirm you in fact have the correct solution. But it was not required. Well, that is not true for this case. When you have an equation with a radical, when you're done with the math and you have your solutions, you have to check each and every solution. It's not uncommon to get what we call extraneous roots. And that's where you do the math and maybe you get one or two solutions. And then when you go check those solutions, oftentimes one of them will not work. You did the math perfectly fine, but it's just that kind of a problem. So please do not forget, once you get your solutions, you have to go back and take the time and plug each solution back into the original equation to see if it actually works. So for this problem, the radical's by itself. It's a positive number. I'm trying to solve for x. Right now the x is stuck under this square root. But we know the way to get rid of a square root is to square it. So I'll square both sides of this equation. And then I end up with 9 minus 5x equals 64. Now it's just a matter of solving that equation for x. I can subtract 9 from both sides. So I have negative 5x equals 55. And then if I divide both sides by negative 5, I get a solution of x equals negative 11. Now I'm warning you, you're so used to solving an equation, and once you get the solution, it feels like you're done, and you're ready to move on to the next problem. But when you have an equation with a radical, you're not done until you absolutely check each and every solution. So that means right now I'm going to take the minus 11, and I'm going to plug it back into the original equation and make sure it in fact works. So my original equation was square root of 9 minus 5x equals 8. So if I plug in negative 11 for x, I get 9 minus 5 times negative 11 equals 8. So 5 times negative 11 is negative 55, but I'm subtracting negative 55, so that means like I'm adding 55. So 9 plus 55 is 64. I should have written it down like this. When I first plugged in the minus 11, I'd like to put a question mark here. Basically saying, is this thing going to be true? Well, now I get to here and I say, well, square root of 64 equals 8, and I got 8 here. It checks out. So x equals minus 11 is in fact the solution. Let's do a second problem, a little bit more involved. Square root of 7 minus x plus 5 equals x. All right. What's the first step? When you're trying to solve an equation with a radical, you've got to get the radical by itself on one side. I'm going to have to move that 5. I'll subtract 5 from both sides. So when I do that, I end up with square root of 7 minus x equals x minus 5. All right, so now the radical is by itself. I don't have to really check a number here because I have a variable on the right-hand side. But now I need to get rid of that square root because I can see that I've got an x tucked under the square root. I'm not going to be able to solve for x with it stuck under the square root. So how do I get rid of the square root? You square it. So as it turns out, you square both sides. So the left-hand side is nice. It just becomes 7 minus x. Now the right-hand side is a little trickier. Let me write out what the right-hand side is going to be. X minus 5 squared means x minus 5 times x minus 5. Please, don't just square the x and square the 5 and think that's correct. That's not correct. When you multiply these out, as it turns out, you're going to get x squared minus 10x plus 25. So I have 7 minus x equals x squared minus 10x plus 25. And now I need to solve this equation. It's a quadratic equation, because you notice I've got an x squared here. So let's get everything on the right-hand side. So I'll subtract 7 and add x. And when I do that, I end up with x squared minus 9x plus 18 equals 0. Now, let's just see if this thing factors maybe. So if my product is 18 and my sum is negative 9, I'm looking for two numbers that I can multiply together that equals 18. But when I turn around and add them together, it equals minus 9. And if I think a minute, how about minus 6 and minus 3? And I think actually that works. So if I factor it, I have 0 equals x minus 6 times x minus 3. And therefore my solutions are 6 and 3. Now once again, here's the big warning. It feels like you're done. You've done some math. You solved the equation. Well, in this case, you're not done. When your equation starts out with a radical, you have to check each and every solution. So I have to take the time to take x equals 6, plug it in the original equation, see if it works, and then turn around and go get my x equals 3 and plug that in and see if that works. So for the 6, I'm going to have square root of 7 minus 6 plus 5 equals 6. And there's a question mark. Is this true? Well, if we look at it, 7 minus 6 is 1. Square root of 1 is 1. 1 plus 5 equals 6. Yep. How about the 3? So square root of 7 minus 3 plus 5 equals 3. Question mark. Now in this case, 7 minus 3 is 4. Square root of 4 is 2. So I have 2 plus 5 equals 3. Does 2 plus 5 equal 3? No, it does not. So therefore, 3 is not a solution. So the actual solution is simply x equals 6. All right. So that's what happens oftentimes. 3 is called an extraneous solution. The math says it's a solution, but when you go back and check it, it's actually not. So it's very important when you're solving equations that have a radical, you have to check your solutions.